Okay, so we're going to keep going. I know that was new to do the middle ticket. We're going to keep going with solving absolute value inequalities. All right? Yeah. So now, I know, it's exciting. Absolute value. So we need to talk about, do you remember what the absolute value symbols mean? Yeah. Do you know what that is? Excellent, very good. How far away it is from 0. So the distance, the units don't matter in terms of how far away it is. So that's why the absolute value of 4 is 4. And the absolute value of -4 is also 4. It's the same, because how far away is 4 from 0? It's 4 units. How far away is -4 from 0? Also 4 units. The direction doesn't matter. What I always tell students when I say this is think about when you're driving. If you drive from here to Austin, right? If I drive from here to Austin, all right, I've made it to Austin. That's a certain number of miles. If I drive from Austin to Houston, it's not a negative number of miles. It's the same number of miles. All right, so think about distance. Cool, physics? Nice. All right, so.
I'm confused.
About?
You said -4 is 4 away from -4.
No, I said -4 is 4 away from 0. We can check the tape, right? -4 is 4 away from 0. Gotcha, right? Throw the red flag. So now, right, go Liverpool, go Reds. Now, when you do this and have the absolute value equal to a number, you're going to set up a disjunction. You're going to set up your own disjunction with the word or, where the answer is one or the other. One or the other. Now, there's a couple of things you need to know. When we do this, your absolute value has to be by itself. So if we have the absolute value of x minus 7 equals 13, I'm not going to write the word or yet, because there's still something next to the absolute value that needs to go to the other side. So that's called isolating the absolute value. We're going to practice doing that. Okay? When you set up your disjunction, I always want you to write the positive one on the right side of the or. See how the positive 3 is on the right side of the or? And the -3 is on the left side. I want you to get practice in that, because tomorrow when I make it even more challenging, that's going to be helpful if you learn how to do that. All right, so let's do one together.
Yes.
All right, we do number 1. Number 1 says 4 times the absolute value of x plus 2 equals 20. Now here's the worst thing you can do. The worst thing you can do is to distribute that 4. That would be the most uncool thing you could do. All right, I will cry actual tears if you do that on the test. Actual tears. So, actual tears. So, we're not going to distribute. That's the most common thing that happens, and it makes me the saddest. So, we need to move this 4 to the other side first before we set up the disjunction. I told you that's 4 times the absolute value. So we're going to divide both sides by 4. All right? If I divide both sides by 4, this 4 and this 4 is going to make 1. So it will be the absolute value of x plus 2 equals 5. 5. Did I do anything to get rid of the absolute value? Camilla, great question. No. Yes, 5 comes after 4. So when you look at this, this is what I call our first checkpoint. If I don't see this checkpoint on your boards, I'm going to get loud. Okay? You know I can get loud. Don't test me. Okay? I know, right? This is the first thing I'm looking for. If I don't see this, okay, you're going to know about it. Fernando. The importance of the checkpoint is if you don't isolate the absolute value, that you're not setting yourself up to get the whole problem correct. All right? Now, do you see how we reached our checkpoint? Camille, this is what your question was asking. All right? See how we reached the checkpoint? Now we're ready to write the word or. Only when you write the word or can you take off, only when you write the word or can you take off the absolute value. Only when you write the word or can you take off the absolute value. We'll get to that tomorrow. Only when you write the word or can you take off the absolute value. Okay? Now watch this, okay? Ready? Yeah. Control C, Control V.
What? Huh? What? Stop, I'm not a
want everyone's brain to see that. Hold on, special. I want everyone's brain that wants to take questions. Shh. Right, just restart. Now, when you move it over on the right side, do you see how nothing has changed?
Yeah.
When I write the word or, the absolute value is gone. Camilla. Like the x was negative, then it'd still be negative here. Everything should be exactly the same. The only thing that was removed was the absolute value. Daniel, because we're making a disjunction. To solve this, Nicholas, we're going to write two of them. Here's one, and the other one is going to be written here in a second.
If we were to keep it, it would be.
We're going to talk about it tomorrow. Daniel? Okay, so Sebastian.
So if there was a negative in front of the x, why would it stay negative if it's an x?
Well, that just means when you plug it in, you make it the opposite first before you start adding to. You're thinking of like all negatives in absolute value become positive.
Yeah.
But if I were to plug in 2 here and it was at negative x, it'd be, okay, what's the opposite of 2? Negative 2. All right, so it's different than what like you're thinking of, they all become positive. It's a different thing. All right, now, on the left side, when I copy this on the left side, watch what changes. It's going to be x plus 2 is the same. That did not change. Equals negative 5. And what I said earlier is happening. I want the positive to always be the one on the right side of the word or. Do you see how the negative is on the left side of the word or? Practice this. I know you're thinking, what? Practice, please. It's going to help you tomorrow. Tomorrow. Everybody good? This is the second thing I want to see. Remember the first checkpoint?
Yes.
Here's the second thing. Let's go Victoria H. and then Camilla. Because if I think about, remember the most basic one was the absolute value of x. Oops.
Whoa.
Go away.
Java.
Just go away. Collapse. Nope. There we go. Thanks for that, Nicholas. So the example on the previous slide was the absolute value of x equals 3. All right? We should know that if I plug in 3 here, what's the absolute value of 3? It's equal to 3. So that's why one of the answers is x equals 3. If I plug in negative 3, what's the absolute value of negative 3? Also 3. So there are 2 answers, Victoria. Negative 3 or positive 3. So this is, wow, Chris, I must be super boring. This is the simple version of what we just did. That's why 1 is negative. Because here's why. If I get this to be negative 5, Nicholas, ready? Your brain's going to get it. If I get this to be negative 5, what's the absolute value of negative 5? Yes, both check marks, and you'll know if you don't. Now, let's solve. We have it over here. Because you get the same answer, but there's more than one answer. There's 2 answers for x. Hold on. Shh. Yes. So I told you this is important because this is like what you're going to do today and tomorrow. If I get x plus 2 to be 5, what's the absolute value of 5, Sebastian? It's 5. If I get x plus 2 to be negative 5, what's the absolute value of negative 5? Also 5. So there's 2 answers that will get me the solution. They both don't equal 5, right? 1 equals 5, 1 equals negative. When you take the absolute value, Sergio, they both equal to 5. All right, so we're going to subtract 2 from both sides. And take a look, guys. It's the same work on both sides. Do you see how it's the same work on both sides?
Yeah.
Now, what happens a lot of times is students think, oh, it's the same work on both sides, so it's going to be one is positive 6 and the other is negative 6. That's rarely going to happen. It does happen, but it rarely happens. All right, this one, the answer is 3. And this one, the answer is negative 7. See, and that's what most students do. Let's go, Camilla.
So does it say it's and both of the
Yes, that's going to be tomorrow, right? If it's and, then both have to make it true, okay? But this is not and, because it's this one or that one. Either one would work. Now, if you wanted to graph this, here's what's really interesting about graphing it. If you make a negative 7 and a positive 3, I know, remember how we said or was disjunction? Right? But those, sorry, okay.
No, I'm saying, are you going to say something different?
I am, yes. Because those were less than and greater than. You're good, Daniel. These are equalities. All right, they're equalities, which means when you graph them, it's just a dot. No shading. Or no arrows. They're both solid, and you're done. No arrows. You're saying
negative 7 is equal to 3.
you're saying -7 when you plug it in would make this true. You're also saying 3 when you plug it in would make this true. Either one works.
Oh, so you're just telling me.
Bingo! Bingo pop.
Wait, no. There you go.
I'm sorry?
There you
What's that?
go.
Hold on, guys. Chris has a question.
If you were to check it, would it still have?
It would. What's -7 plus 2? -5. What's the absolute value of -5? 5. 5 times 4 is 20.
See that, but that's what I was asking. If it's an absolute value, then why did you say that should still be negative?
X would still be
On
negative.
the first checkpoint, you said that we're within the x.
This checkpoint?
Yeah, no. If the x had a negative,
You're trying to go down that road again, and I'll give you a problem that has a negative. I'll give you a problem later. Okay? Not probably today, but I'll give you a problem later. All right?
email me.
Now, if you'd like to email me, go for it. Does everyone see number 2?
Yeah.
Randy, still with me? You're good. Here we go. Number 2. Do you see how the absolute value of x is not by itself? Do you see how there's a -3 that's next to it? Does everyone see the -3 that's next to it? All right, we need to move it to the other side. So write +3 on both sides. So now I have, if I go this way, the absolute value of x equals 7.
And we do that thing.
Now, this is the checkpoint, the first one. Because Camilla's brain said, how do we know if we're at the first checkpoint? Is there anything in front of the absolute value?
Oh.
Is there anything behind it on this side? No, that's how you know.
Oh,
There can be stuff inside it, right? Stuff inside it is fine. Stuff inside is fine. Just not stuff in front of it, not stuff behind it. That's the first checkpoint.
why don't we put, I would say between or and and.
Today, right now, for the last 15 minutes, it's always going to be or. Tomorrow. Okay? So today, for the last 15 minutes, it's or. So we did our first checkpoint, which means I am ready and able to write the word or. Okay, yes? Question?
Or what?
What am I going to write on this side?
X equals
X equals the +7 on the right side. What am I going to write on the left side? X equals -7. Now you should notice that because the absolute value of x didn't have anything inside of it, like x plus 2 or x minus 4 or 2x plus 6 or whatever, there's nothing in there with it. So it's a very straightforward. Your second checkpoint is done. That is not going to happen often, right? Most of the time it'll be like this, where there is some more work to do. Great. What if there not a box in the absolute value? What if it was like 3x? This would be 3x equals 7, or 3x equals -7. You would divide both sides by 3 to get your answer. It'd be the same thing like you do.
So we put a check mark or we do that?
If you don't put a check mark, that's okay. But I'm going to be looking for these two things, Camilla. Everything after, right, is stuff you should know how to do. The stuff that's brand new are these two things. So if I see, what I see a lot of the time, Camilla, and it drives me crazy. What I see all the time is kids write or, and they've got absolute values on either side of or. And I lose my mind. All right? If you write the word or, I better not see any absolute value. Now,
So at least that and I thought.
we're going to get there tomorrow. I know you really want the word and, but it's not coming today. But don't worry. Tomorrow. Everybody good on number 2? I just plotted those points. Yes, Victoria V. If it doesn't say graph, you don't have to. I'm just showing you what it looks like. You don't have to graph if it doesn't say graph. Everybody good? Now, you have 13 minutes. Because we already did the exit ticket, right, the middle ticket, we don't have to worry about something at the end of class. So you are going to have 13 minutes to do all 6 of these. You got a bunch of time to do all of these. All right, I'm going to be looking for those check marks. If I don't see it, you're going to know. All right, you're going to know if I don't see that first checkpoint and the second one. All right, give it a go. Write small.